Okay, hey. If you're watching this, then it's probably Thursday night, now that the quiz is Friday. And that's fine. We're going to talk about, I think that I decided, and hopefully this is the right decision, but I think I decided in this video I'll do the evens since I already made a print answer key for the odds. So that way for the odds that you have to actually do and turn in, you'll have the print answer key that you can look at and work off of. And if you're coming here to watch the videos, then it means you need extra help anyway. So do the evens. And the evens should be similar to the odds. It'll give you a chance to try them yourself and then kind of get some feedback from me. So I like that idea. We'll see how it goes. So anyway, since we're doing the evens, let's jump in on number 2. So number 2 is this guy. So we're starting on the product rule worksheet, by the way, if that wasn't obvious, but CA1, this is from that website I've been using it. That means corrective assignment, meaning an assignment that helps you correct your mistakes for the product rule. It's the first one. We're doing number 2. So that's 2. Let me get everything else out of the way. Okay. So again, I'm going to show more work than I need to and show more work than you need to, just to make sure that we're all sort of on the right page. But look in here, there's not really anything I would do to simplify these. When I look at these, I just see 2 factors. I know that to do this derivative, I would have to do the product rule. So that means that h prime of x would be the derivative, d dx, of the 3e to the x. And then you would just multiply that by the other factor, the 2 minus 7x. And then you'll add to that the first factor, the 3e to the x. But you'll multiply that by the derivative of the second factor. So I'm going d dx again. And this time I'm doing d dx of the 2 minus 7x. This is the setup. You would not and should not show this step. It would be perfectly fine for you just to jump right here. But again, if you understand what we're doing, then we're differentiating this guy. Now technically we would pop that 3 out. And really we're just differentiating the e to the x, and the derivative of e to the x is e to the x. But then we're multiplying by that 3. So you get 3e to the x. This function is its own derivative. Then you multiply that by the 2 minus 7x. We're just bringing that down. We're not differentiating it, so just bring it down. Then the 3e to the x, it looks a lot like a k, but that's an x. So it's 3e to the x. Now we're doing the derivative here. Now, the derivative of 2 is 0. So I'll write it, but technically you're getting 0. Then you're going to subtract the derivative of the 7x, which is just 7. So we're ending up with a derivative that's negative 7. So this has given me, I guess I would distribute the 3e to the x. So I'd get 6e to the x minus 21 x e to the x. And then this, I guess I shouldn't have drawn that plus. This would be, since this is just a negative 7 really, we get negative 21 e to the x. So you should notice that this is an e to the x term and this is an e to the x term, but this guy in the middle is an x e to the x term. So these 2 terms at the ends will combine. I can actually take away 21 from 6 to get negative 15 e to the x, and then minus 21 x e to the x. And then technically, not to be annoying or anything, but this first term has only 1 x in it. So that's kind of like a degree 1 thing. Now this has 2 x's in it. It has an x and an e to the x. So this is like a degree 2 thing. So technically, to be in simplified form, that should be the guy that comes first. Negative 21 x e to the x. And then the minus 15 e to the x. And then from here, of course, we can factor out our common factor. Since both of these guys are negative, I'll certainly pop out a negative. My common factor is just 3. And of course the e to the x too. And if you factor that out, then you're left with 7x plus 5. And then that for sure is the best we could do. By the way, the whole derivative happened right up here, like in this first step. Everything else was just simplifying. Simplify, simplify, simplify. So that's really what we need to be practicing, I think, is we need to be practicing mostly with our ability to simplify these things algebraically, because doing the derivative doesn't tend to be very hard. It's rewriting your answer in the cleanest possible form. But hopefully we all agree on that. This again was number 2. So from 2 we'll go to 4. So here's 4. Make it bigger. All right, so for this one, I guess we have some choices here. Technically, it's on the product rule worksheet, so they pretty obviously want us to do it as a product. But this is a good opportunity to talk about how, again, you really have a lot of sort of choices here. You could do a few things. If you were going to do this as a product, then you'd probably rewrite 5 over x as 5x to the negative 1. And of course leave cosine as cosine. But now you probably see more clearly what our two factors are. You've got this rational factor is now expressed as a power function, so we can more easily take the derivative of it. This still, by the way, is plain old g of x. You haven't differentiated yet, so don't say g prime. But the other thing you could have done here for sure, especially on the quiz, because the quiz will be more mixed up. You're not going to know which one is a quotient, which one's a product. So you might look at something like this, and you might choose to call it 5 cosine x just over x. And honestly, maybe this would be easier to do as a quotient, because the derivative of x is so easy. That's just 1. Here, when I do the derivative of this, I'm going to end up with a negative 5x to the negative 2. I'm going to have to clean up the whole negative 2 thing. But both methods will take you to the same place. So you know what? It dawns on me, maybe I should do both methods. You can see for yourself. So how's about in green? We rewrite the function this way, and then we apply product rule. We would get a g prime of x that equals this guy's derivative, so negative 5x to the negative 2, times this guy, so cosine, then plus this first guy, 5x to the negative 1, and then times the derivative of cosine, which is negative sine. And then technically that's it. This is my derivative, but it's not clean at all. I've got 2 negative exponents. I'm adding a negative. There's all sorts of stuff we would have to fix here. So let's start fixing. First thing is this x would want to get moved down to the denominator, so we would have a negative 5 cosine x. But then down in the denominator would move our x to the negative 2 and make it x to the positive 2. Then this says plus, but we're adding a negative, so we'll make it a minus. And again, we'll do a 5 and a sign in the numerator. But this x to the negative 1 will boot that down to the denominator, make it x to the positive 1. Then from there, if I wanted to combine these two terms, and I definitely do, then I would need a common denominator. So you'd multiply this term by an x over x. And that'll get you an x squared in the denominator. So from there, I'm going to stick to the green, I guess. You would now have a big old fraction whose denominators are both x squared. So the denominator is x squared. In the numerator, you got a minus 5 cosine x. And we're going to take away from that this thing, which will end up being 5x sine x. Which brings us pretty close to our final and best answer. I certainly see a common factor of negative 5, so I'll pop that out. I think I'll put the negative out in front of the whole fraction, like you know I like to do. Then I'm factoring out a 5, leaving me with cosine x minus x times sine x. And then I don't think we do any better than that. So So that was product rule, which is what we probably should have been doing because it's on the product rule worksheet. But let's do it again as a quotient rule problem. And I think you'll see that it feels a little bit easier. So doing this, we would go again to the same g prime. And again, we want the derivative of the numerator, so that would be -5 sine x times the denominator, so times another factor of x, then minus the numerator, so 5 cosine x, times the derivative of the denominator, which is technically just 1. And then that's all over x squared. So look how in basically one step, we're like way down here already. The two terms are reversed, I guess, in the numerator, but we kind of skipped all this mess up here, and we're definitely going to get where we're going a little bit faster. So what are we doing? Well, we're just factoring out a -5, and then we're basically right where we need to be. So if you pop out a -5, then the way I differentiate it, I've got my sign first, and then we're subtracting, or I guess we're adding. Did I screw that up over here? I did. I'm factoring out a negative, so both of these signs should have changed. This needs to be plus, so that's my bad. Over here I didn't mess it up. I'm factoring out a negative, so this goes to plus, and it would be oh no, I'm screwing up again. I missed this x, so this is x sine x and then cosine of x, and then it's all over x squared. So this is basically the same answer because the stuff in parentheses, of course I could switch that order because it's addition. Addition's commutative, and I guess I would say that technically this second answer is the better one because, as I explained before, this guy has two x's. So if we're going in descending order by the degree of the expression, then the thing with two x's should come before the thing with one x. And sure, I'll make that change because it's important enough, I guess. I think if you didn't do that on a quiz, that would probably be one of the things that maybe I would mark it to remind you, but I wouldn't take off points. But technically we should have the x sine x coming first, and then add to that cosine x. But that's it. I guess if you practice enough, you'll see that doing this problem as a quotient would turn out better than turning it into a product and doing it that way. Anyway, hope that was helpful to see it done both ways and to start sort of figuring out which way is easier. All right, after 4 comes 6. And these, I don't know, I think a lot of people were doing really well on these, but I think there were a handful of people that were pretty confused. So let's find out. Looking at part A, it says find h prime of -1, and one thing you might want to make a note of is when the quiz does roll around, I'm sure I'm going to break this down into 2 separate questions, and it might look more like this. I'll say something like, hey, Roman numeral 1, I'll say find h prime of x, where for sure I just want the derivative in general, and then there'll be a whole other part. In part 2 I'll go, okay, now that you've got the derivative, find me h prime of -1. But I definitely want you to work from the general then to the specific. So don't be plugging stuff in too early, because A, you're honestly more liable to make a mistake, and B, I expect to see the general derivative before I see any final answer. So what's this look like? Well, for part 1, where I'm just working in general, the derivative of h would be h prime, of course. And of course we'll find that by doing the derivative, d dx, of, what do we got here? A 2 and a j of x and a k of x. So as I look at this, I see a function that has a constant multiple. So for sure this 2, I would just grab that 2 and pop it out of the derivative. And I would worry about the 2 at the very end of the problem. I'm going to worry first about doing my derivative. Now the only thing left inside of the derivative are my 2 functions. I'm multiplying them. It's just literally straight up exactly what the product rule is for. So I'll take my 2, I'll open a set of brackets because I know the product rule is going to be j prime of x times normal k, and then plus j times k prime. But when I say give me a general rule, this is what I mean. This is my derivative. I couldn't simplify it any further, but there it is in general in terms of x. So that means now I'm ready in part 2 to go ahead and just let x equal -1, and I can do h prime of -1. And hopefully what kind of made sense to me was here, well, I've got a 2, obviously break down a 2, then I got to open some brackets. Now j prime of x, that's just going to be, well, alright, I'm jumping the gun a little. That's going to be j prime of 1. Let's do all that substituting. So I want j prime of -1, then I want k of -1, then I want j of -1, then I want k prime of -1. So the way this should feel is it should feel like you've just got a 2 and you're multiplying that by some number times some number plus some number times some number. And all of those numbers, you just come up here to the table and grab them. If you want j prime of -1, then remember all these values in the bottom row are what you would get when x is -1. So j prime of -1 is just here. It's the -4. Pop it in. And then k of -1 is right here. It's the 5, so pop that in. Then j of -1 is this first guy. It's the 3. Pop it in. And k prime is the last one, so it's -6. And now just follow order of operations. Keep that 2 on the outside. Multiply first, so -20, plus multiply these, so -18. That's giving a 2 times a -38, giving us a final answer of -76. And that's it. That's how we're doing that. Now maybe B is the one that feels a little bit weirder. But looking at B, again, what I would do first is I'd probably rewrite the expression a little bit. First, let me just make a copy of it, cover that up. We're doing part B now. Get rid of this crap. Okay, so now this time we got a function called f. And we are after the derivative, but first I would rewrite this just a smidge. Instead of j of x divided by 2, just think of that as a j of x that's being multiplied by 1/2. And then you get your -4. Then you got your 1 minus k. And again, this is just another straight up product rule, but this time the two functions we've got are this whole pink thing and this whole green thing. But we should still know that the derivative of f prime, that's still just going to be the derivative of the pink times the green. And then the normal pink times the derivative of the green. We're just following the same pattern. It'll all be with a plus sign in the middle. So what goes here in the green? Well, I want the derivative. Now the derivative of this, technically, you would do the derivative of the first term. You'd pull out the 1/2 and just let that kind of wait, and you just get j prime. But you would still multiply that by 1/2. Now you would go to do the derivative of the -4, but the derivative of a constant is 0. So that -4 just kind of falls off. We're just going to get 1/2 times j prime of x. Then for k, we of course have to bring this whole thing down. 1 minus k of x. Now over here in the pink, we just bring this whole function down. So it'll be the whole 1/2 j of x minus 4. And then in the green, we're doing this guy's derivative. And the derivative of 1 is 0 minus the derivative of k. So it'll be negative k prime. But this is it. This is our derivative, which means I guess we're ready to just start substituting in. So they want f prime of -1. So that means I need a 1/2 times j prime of -1, that's still -4. Then I want to multiply that by 1 minus k of -1, that's the 5. Then we'll add to that 1/2 times j of -1, so 3. We're subtracting 4 from that, and that should all be in parentheses. And then we're going to just do negative. Now be careful here, because what happens here is we're multiplying. but we're multiplying by the opposite of k prime. So it'll be negative negative 6 is what it is. All right, so what's that giving me? This is going to be a negative 2 times a negative 4. Then we're adding to that half of 3. Is this the one that comes out with a fraction? That's annoying. But I'll do this math off to the side, I guess. So that's going to be a 3 halves minus 4, but we'd rewrite the 4 as 8 halves, and then we see we end up with negative 5 halves. And then that's getting multiplied by positive 6. So we now have a positive 8 minus, and this is going to be what? 30 over 2, so 15. And then there's your negative 7. But that's how pretty much all of these problems go, where you've got the table of values, is you just kind of follow the rules of differentiation. I mean, these functions feel weird because it's like some other function with operations being done to it, but just do the derivative like you normally would, and then substitute in, and you'll get an answer. All right, that's 6. So what about 8? I'm skipping 7. I already did 7, remember, and there is no 8. Great. So let's go on to the next batch of problems. This is now corrective assignment number 2, but we're still talking about the product rule. So looking at number 2, okay, yeah, so for number 2, let me just move that over there, make it bigger, and again, give myself a bunch of space by whiting everything else out. Okay, so yeah, I mean, this again is just another sort of early problem on the product rule. This should be fairly straightforward. Again, it's exactly like the last one in that we would want to rewrite this, but we've got two choices. We could do the 1 over x as an x to the negative 1, and then the other guy is 6x minus ln of x. But we already saw how doing this as a product rule problem actually got ugly pretty fast. So we, if you remember, are actually better off just expressing this as a fraction and doing quotient rule on it. So go ahead and just put 6x minus ln of x in the numerator, and then just divide by the x. And then from here, I would do this product as quotient rule. Even though it says product, just do quotient, because on the quiz, on the quiz, you're going to have that opportunity. I think pretty much always is however you see a way to do the problem, you can do it. If you can do it by rewriting it and then using power rule, do it. If you see a way to do it as quotient rule instead of product rule, that's fine. And if you see a way to do it as product instead of quotient, that's fine. But now that I'm set up, we would find g prime by doing the derivative of the top. And since the top is 2 terms, you just do the derivative of the first term, getting 6. Then subtract from that the derivative of the second term, which is 1 over x. Then you multiply that by the denominator, which is x. Now quotient rule, so we're subtracting, and I want the whole numerator, 6x minus ln x. And then I want the derivative of the bottom, which is literally just a 1. And then the whole mess should be over x. Now I would say maybe this was a bad idea because we now have a fraction within a fraction, but we pretty conveniently now have a factor of x that you just distribute that in. And then you would get 6x. And 1 over x times x is x over x, so that whole thing is just a 1. Then here, my negative distributes in onto that term and that term. It does not also distribute onto the 1, though. It only distributes onto one factor, not both. Now this factor happens to have 2 terms, so it has to distribute onto both terms. So when I do distribute that, I'll get a minus 6x, then I'll get a plus 11x. I'll get a plus ln of x. And then the 1 is nothing, but this will be all over x. And you'll pretty quickly notice that 6x and negative 6x actually just cancel out. So it looks like we're getting an ln. Ooh, I blew something. Don't forget your denominator is squared, of course. And that's squared. So in the numerator, I think I'm putting the ln of x first. So ln of x with parentheses minus 1. That's my numerator. Divide that by x squared. that's my final function, I would say. Yeah, I'm happy with that. Okay, that's 2. And here's 4. Which looks pretty similar. Like really, really similar to some of the other stuff we've already done. And probably the easiest way to sort of attack this would be to say that g prime is going to be the derivative of this whole thing, but that 3 is a constant, so remember you just pop the 3 out and just do the derivative of ln of x times sine x. And at that point you're looking at a pretty straightforward product rule thing. So we've got a 3, open a set of parentheses, then I want the derivative of that, so it's 1 over x times a sine x. Then I don't want to differentiate ln, just bring that down, but I do want to differentiate sine. That gives me cosine. And now what? I guess what we got to do here is see this as a sine x over x. And then this guy needs to be over x too. So we need a common denominator. So if we multiplied by x over x, then we would end up with ln of x, cosine of x, and x in the numerator. And that would be all over x. But that would allow me to combine everything down now into a single big old fraction. This term, I suppose, it's got 3 x's in it. That one wants to come first. And in what order? What order is best? There's no great order here. Certainly the x wants to come first. So it would be x times the ln of x times the cosine of x, and then plus sine of x. And then the whole thing is all over x. And just be careful. Remember, you absolutely cannot cancel this x with this x, because you can only cancel things that are common to both terms. If this sine also had an x on it, then we would cancel by first factoring out the 2 x's and then canceling. But here nothing cancels, and this answer here is the end of the road. Okay, so what about 6? 6 is going to be the table thing again. I'm going to go through this much faster now because hopefully you get it from last time. But we're going to find h prime of t first, which again basically just means treating this negative like it's a factor of -1, and then just pulling it out and doing the derivative on the other 2 guys, f and g. So sort of here's like an initial setup, and again all of that hopefully just is happening in your head. You just know that we're going to just pull -1 to the front, differentiate the stuff that's left, and then distribute a -1 through at the end. So this will be -1, and then literally just product rule. It's the derivative of the first times the second plus the first times the derivative of the second. And that's good. We're all well and sorted now, so we can now move on to finding h prime of -3. And again, that's just values being plucked from this table. So it's going to be a -1, and f prime is giving 2. Plain old normal g is giving 3. Normal f is giving a -6, and g prime is giving -1. So this will be a -1 times 6 plus 6, sure. So I'm getting -12. That's it. Okay. So for part B now, which I'll move over here, looking good, and I'll white out the other stuff just so it's not distracting us. Okay. Okay, again, not much you can do here. You just kind of have to go at it. But I see a whole first factor that's all that. And then you've got this second factor that's all that. And so to get to a derivative, we would have to differentiate the both of those. So to get to b prime of t, we're going to do this guy's derivative. The derivative of the 3ht, you'd pop out the 3, differentiate h, getting h prime, then you'd multiply by 3 again. So essentially just when I'm differentiating, you're kind of just bringing on your constant multiple. The function turns into h prime, but the derivative of this -2 of course makes 0, so that's just going to be gone. And then I want to multiply that by the other factor, which is f of t minus 1. Okay, plus this time I'm bringing the pink guy down, so 3 times h of t minus 2. And then the derivative of this is just f prime minus 0, so it's really just f prime. Okay, so now that I've got my derivative, I know that what they really want me to find is b prime at 1. So again, you're just going to be doing 3 times some number, and then some number minus 1, then you're going to add to that 3 times some number minus 2, and then you're going to go some number. So again, who are all these things? We need h prime, so that's going to be the 2. Plop it in. Then we need f, which is giving 4, so it'll be 4 minus 1. H of t is worth 4 also, and f prime is worth 6. So to find the value we're looking for, just work this out. So I'm looking at a 6 times 3, then we're adding to that 12 take away 2 is 10 times 6. So it's 18 minus 6 plus 60. Okay, I don't remember this answer, but 78 it says. And I gave you an answer key, so you could always check. 72. Oh no. I don't know what we're doing. Hold on. We're doing 7? 7's odd. Why did I do 7? Oh, I made a big mistake. Oh well. You guys are getting 7. I'm not going to go back and fix it. But 7b should be given 36. And I'm getting that. So I messed something up. So I'll pause it. Okay, found my error pretty quickly. Right here. It says f of t. Oh no. Yeah, it says f of t. But I grabbed h of t and plugged in a 4. We need f of t. So this 4 right here is supposed to be a -3. And I think that's hopefully the only mistake I made. H of t, that's the real 4. And f prime is 6. So yeah, if I just tweak this now, then I'm still getting 6, but this is now -4. And the rest of that should be right. So I'm now, instead of adding 18 to 60, I'm taking away 24, which does in fact lead us with 36, which we know is right. Okay, sorry about 6b. Figure it out. Ask me about it tomorrow. Okay, and that is also us ending all the problems on product rule. So I'll stop here. We're at 33 minutes anyway, so I'll stop here and then I'll put out a second video with all the quotient rule stuff. See you then. Bye.